You're welcome to the Scholar School. We establish our footprints on the
Welcome to the Scholar online class. I'm your tutor for today, Mr. Sam. So today under chemistry, we'll be looking at another interesting topic in chemistry, which is gas law. And today we'll be talking about Boyle's law, Charles law, and we'll be talking about the general gas law, or rather general gas equation. Now, gas law is a very important topic in chemistry because it shows the relationship between the pressure, volume and temperature of a gas. Now, Robert Boyce conduct an experiment and show the relationship between the pressure and volume of a gas. Boyle's law states that the volume of a given mass of gas, or in some textbooks, the volume of a given mass of gas is inversely proportional to the pressure at constant temperature. What Boyle's law is trying to say here is that at constant temperature, the volume of a fixed mass of a gas is inversely proportional to the what? To the pressure. Or you can say the pressure of a fixed mass of gas is inversely proportional to the what? To the volume at constant temperature. So mathematically it can be expressed like this. It means the pressure of a fixed mass of gas is inversely, when we say something is inversely, it means it is 1 over inversely proportional to what? To the volume of what? Of that gas at constant temperature. We have our temperature to be what? To be constant. So we want to remove this inversely sign and introduce our constant. P equals to what? K over V. At this point, our K is acting as our what? As our constant. So let's make K the subject of formula. Our K is equal to what? PV. This is mathematical representation of what? Of Boyle's law. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to what? To the volume. So at this state, if this pressure and volume undergoes an extension or expansion, then the new product is what we call the final product. At this point, if this pressure and volume undergoes expansion, it will bring a new product. A new product will be formed, which means if this pressure and volume undergoes expansion, a new product will be formed, and that new product is what? The final pressure and what? The final volume. So which means Boyle's law mathematically can be said to be P1 V1 equal to what? P2 V2 for Boyle's law. Now, Charles law. This man carried out an experiment and he shows the relationship between the volume and temperature of a particular mass, of a particular gas rather. His full name is Jacques Charles. You never might tell, that might be your OBJ question in Jamb. And for boys, Robert Boyce. Now, Jacques Charles states that the volume of a given mass of a gas is directly proportional. For Charles law now, the volume of a given mass of gas is directly proportional to its what? To its absolute temperature at constant pressure. For Boyle's law, the temperature is constant. While for Charles law, the pressure is what? Is constant. It means if this pressure is doubled, then the volume will be what? Will be halved. Do you understand? If this pressure is doubled, then your volume will be what? Your volume will be halved. For Charles law, the volume is directly proportional to what? To temperature. I introduce my constant K. Making K the subject of formula, we have K equal to what? V over T. Now if this volume and temperature undergoes expansion, it will produce a new product which we have V1 over T1 equal to what? V2 over what? Over V2. Indirectly it means that if this volume is doubled, if this volume is increasing, then the temperature will be increasing. If the volume is increasing, the temperature will be what? Increased. Now that is another OBJ question in Jamb. They might just ask you that what will happen to the temperature of Charles law? In Charles law, what will happen to the temperature if the volume is what? Is increased. Now in Charles law, if the volume is increased, the temperature will also what? Be increased. Now in Boyle's law, if the pressure is increased, the volume will decrease. If the pressure increase, the volume will what? Decrease. We are going to establish that very soon when we start solving questions related to Boyle's law and Charles law. Now these are the formula for Boyle's law and the formula for what? For Charles law. Now the general gas law is just like saying the general gas equation. The general gas equation is an equation that comprises both the Boyle's law and what? And the Charles law. And the law is stated as P1 V1 over T1 equal to P2 V2 over T2. Now this is the general gas equation. Now you might be given a question. Now some students do ask that how do I recognize the kind of law to apply in some questions, in solving questions. Now to understand the kind of law you are going to use in a particular question, when you are given a question and from that question you have your pressure, you have your volume, and the question is telling you that at constant temperature, just know that you are using Boyle's law. The question says you have pressure, you have volume. Your pressure will be given to you and your volume will be given to you. Now if you have pressure and volume, directly you are using what? Boyle's law. If you have a question and in the parameters in the question you have volume and temperature, that means you are using what? You are using Charles law. Now in some cases I've seen students mixing up the equation together. Now they will represent P1 V1 equals to P2 V2 as Charles law. That is wrong. Once you know the law and you can state the law, that Boyle's law states that the volume of a gas is inversely proportional to pressure, or you say the pressure of a gas is inversely proportional to what? To volume. While Charles law is directly proportional, it's a two different things. Boyle's law is inversely proportional and Charles law is what? Directly proportional. For Boyle's law, the temperature is constant, while for Charles law, the pressure is what? Is constant. Now, I want to list out some things now. We have what we call STP, standard temperature and pressure. STP, standard temperature and pressure. This standard temperature and pressure is the acceptable terms or units by which pressure and temperature is what? Is measured. For temperature is equal to Kelvin. It's measured in degrees Celsius and also measured in Kelvin. But the standard measurement for temperature is what? Is Kelvin. And we have a value for this Kelvin, which means at 0 degrees Celsius, a temperature is equal to 273 Kelvin. 273 Kelvin, which means if you are given a question and the question is telling you that at constant temperature, it means your temperature is equal to what? 273 Kelvin or 0 degrees Celsius. So which means our T is equal to 0 degrees Celsius and also equal to what? 273 Kelvin. Are you with me? 0 degrees Celsius is equal to what? 273 in Kelvin. Now for pressure, I'm just listing some terms by which pressure and temperature is measured. For pressure is measured in Pascal. It is measured in Pascal. It is measured in ATM. It is measured in torr. It is measured in millimeter mercury. It is measured in Newton per meter square also. Now, for millimeter mercury, pressure is equal to 760 millimeter mercury. So which means our standard value for pressure is equal to what? 760 millimeter mercury. Now for torr, in torr, pressure is also equal to 760 torr. Are you with me? Pressure is measured in 760 millimeter mercury. It is measured in millimeter mercury, and the value for this millimeter mercury is 760. While for torr, it is what? 760 also. Pressure is also measured in what? It is measured in pascal, and the value is 101,325 pascal. 101,325 pascal. Now pressure is also measured in Newton per meter square, and the value is 101,325 Newton per meter square. So I can say that my pressure, that 1 millimeter mercury is equal to 1 torr. Are you with me? 1 millimeter mercury is equal to 1 torr. Oh, I forgot to add that pressure is also measured in atm, and the value is 1 atm. So which means I can say my pressure is equal to 1 millimeter mercury. 1 millimeter mercury is equal to 1 torr, and also equal to what? 1 atm. Sorry. Okay, my pressure is equal to what? 1 millimeter mercury, and is equal to 1 torr. Now let me explain, let me break it down. From here, I said pressure is measured in millimeter mercury. That is 760 millimeter mercury. That's the standard value for pressure. In torr, now this millimeter mercury and torr is just a unit by which pressure can be measured. Just like we have volume. Volume is measured in meter. It is measured in meter cube. It is measured in decimeter. So pressure is measured in millimeter mercury, measured in torr, measured in pascal, measured in Newton per meter square, and also measured in atm. Because you might have a question and you'll be giving pressure to be what? 1 atm. 1 atm, which means the question is telling you to solve in what? In atm, and leave your answer in what? In atm. So if pressure is equal to 760 and torr is also 760 here, it means 1 millimeter mercury is equal to 1 torr. Since the two of them they are the same, 760 millimeter mercury, 760 torr. We can also say for this that 1 pascal is equal to 1 Newton per meter square. Since our pascal is 101,325 and our Newton per meter square is also 101,325, we can say 1 pascal is equal to what? Is equal to 1 Newton per meter. So having said that our temperature is equal to 273 Kelvin, and in Celsius it is 0 degree. While pressure is what? Is measured in millimeter mercury, 760 millimeter mercury. Pressure is also measured in torr, 760 torr. Pressure is also measured in pascal, and the value is 101,325. And also in Newton per meter square, it is 101,325. And also it is measured in atm, which is what? 1. The value is what? The value is 1. So let us look at some questions and solve under Boyle's law, Charles law, and general gas. This question is related to Boyle's law, Charles law, and general gas law. Number 1, we have what is the temperature of a given mass of gas initially at 15 degrees Celsius and 18 atm if the pressure is reduced to 6 atm at constant volume. The question is asking us that what is the temperature of a given mass of gas? What is the temperature initially at 15 degrees Celsius and 18 atm if the pressure is reduced to 6 atm at constant volume? Which means the first thing to do when solving question like this is to write out your parameters first. For Jamb candidates, there might not be time for you to start writing out your parameters. That is why practice makes perfect. If you start practicing now, then this question is a question that in just 30 seconds you should be done for Jamb. 30 seconds you should be done. Now the first thing to do is to write out your parameters. Now let's look at the parameters of a gas initially at 15 degrees Celsius. I told you earlier that temperature is measured in what? The standard temperature is measured in Kelvin, but we have temperature in what? In degrees Celsius. 15 degrees Celsius. That temperature is measured in what? In Kelvin, but we can have temperature in what? In Celsius also. 15 degrees Celsius. Now that is our T1 initial temperature. Now and 18 atm. I said also that our pressure can also be measured in what? In atm. So our initial pressure is what? 18 atm. Now we have to convert this temperature from degrees Celsius to what? To 273 Kelvin. We have to convert from degrees Celsius to what? To Kelvin, because that is the what? Standard temperature. Standard value for the unit for temperature plus 273 Kelvin. Now to convert from degrees Celsius to Kelvin, you have to add what? 273 Kelvin. Are you with me? So 15 degrees Celsius plus 273 Kelvin, that is equal to 288 Kelvin. Now our P1 is equal to 18 atm. Now the question says if the pressure is reduced to 6 atm at constant volume, it means our P2 is equal to what? 6 atm. Our T2, which is what we are looking for, on load. Now let's look at the formula. We have Boyle's law, which states that P1 V1 is equal to what? P2 V2. Here we have the pressure and the volume, but for the question we have pressure and temperature, we don't have the volume, which means we can't use this formula. Now Charles' law, V1 over T1 equal to what? V2 over T2. For this formula we have the volume and the temperature, but from the question we have temperature and pressure. Now this formula does not have pressure, which means this formula is out of it. Now the general gas equation, P1 V1 over T1 equals to P2 V2 over T2. Now for this law equation, we have the pressure, volume and the temperature. Now from the question we have pressure and what? Temperature, which means we can use this formula because it has what? Pressure and what? And temperature. But the problem says at constant volume. At constant volume, it means our V1 is equal to what? Our V2 at constant volume. It means our V1, the initial volume, is equal to the final volume. That is it means that this volume is at what? Is constant. So we are making use of P1 V1 equals to P2 V2 over T2. So at constant volume, since our volume is equal to each other, it means we are left with P1 over T1 equal to P2 over T2. Now our initial pressure 18 atm, 18 over our T1 288 Kelvin equal to our P2 6 atm. You can decide to write the unit while you solve so that you will not forget. Then your temperature X, that is what we are looking for. So from here you cross multiply. So we have 18x 18x atm equal to 288 Kelvin multiplied by 6 atm. Now from here 288 multiplied by 6 is equal to 1728. We have 18x atm equal to 1728 atm Kelvin. Now we divide both sides by 18 atm since we are looking for x. So we have x equal to 1728 atm Kelvin divided by 18 atm. This atm becomes atm. So we have 172.8 divided by 18. That is what? 96. Our x is equal to what? 96 Kelvin. Now let me explain again. Now from the question, The temperature of a given mass of gas initially at 15 degrees Celsius and 18 atm. Initially, our temperature is what? 15 degrees Celsius. So we converted from degrees Celsius to what? To Kelvin. And to convert from degrees Celsius to Kelvin, you have to add your what? Kelvin, 273 Kelvin. You have to add 273 Kelvin. Now, our initial pressure is what? 18 atm. And the question says if the pressure is reduced to 6 atm at constant volume, the pressure was reduced to 6 atm, which is our final pressure, and we are looking for our final temperature. Now, we decided to check Boyle's law, if we can use Boyle's law, and found out that Boyle's law does not have temperature, and from the question we have temperature. Now, out of it, now for Charles' law, V1 over T1, we have the volume and the temperature, while from the question we have pressure and temperature. So Charles' law was also condemned, and the general gas equation, which comprises of Boyle's law and Charles' law, P1 V1 over T1 equal to P2 V2 over T2. So we have the pressure and the temperature, and the question says at constant volume, which means our V1 is equal to what? Is equal to what? To V2, since it is constant. So we have P1 over T1 equals to P2 over T2. Then we input our parameters, our values, and then we substitute for what? For T2. Now going to the second question. The second question says, a given mass of a gas occupies a volume of 300 cm3 at 900 mm mercury pressure. Calculate the volume occupied by the same gas at 750 mm mercury if the temperature is held constant. The parameters have been given. We have 300 cm3 for the volume, which means our V1 is equal to what? 300 cm3. At 900 mm mercury pressure, our P1 is equal to 900 mm mercury. Now the question says calculate the volume, which means we are calculating for V2, unknown, occupied by the same gas at 750 mm mercury. Our P2 is now 750 mm mercury. Now looking at the parameters, if the temperature is what? Held constant, it means the temperature is what? Held constant. Now looking at the parameters, we have pressure and volume. Now, as you are writing the parameters out, then you should start thinking that, okay, what kind of law am I going to apply? What kind of equation am I going to use to solve this equation? Now, Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume at what? Constant temperature, which means we are going to be using Boyle's law to solve this question. And the equation is P1 V1 equal to P2 V2. Now, let's input our values. P1 is what? 900 mm mercury. You can decide to write your units as you solve. And V1 is what? 300 cm3. Our P2 is what? 750 mm mercury. 750 mm mercury. And our V2 X. Now let's multiply. 900 mm mercury multiplied by 300 cm3. Mercury multiplied by 300 cm3. We have 270,000 mm mercury cm3. So here we have 750 x millimeter mercury. Now we are looking for x. So the next thing to do is to divide both sides by what? By 750 millimeter mercury. So now we have 750 millimeter mercury. Here 750 millimeter mercury. So from here now our x is equal to now from here our x is equal to 360 centimeter cube. Now I made a statement earlier when I was explaining Boyle's law, Charles' law, and then the general gas law. I said for Boyle's law that if the pressure is increasing, then the volume will decrease. For Charles' law, I said if the volume is increasing, the temperature will also increase. Now, but for Boyle's law, if the pressure is increasing, the volume will decrease, and if the pressure is decreasing, the volume will increase. Now, let's look at this question. For the initial pressure, our initial pressure was 900 millimeter mercury at 300 centimeter cube. The question says, now since the pressure was reduced to 750 millimeter mercury, it means your answer for the volume must increased. Now for 900 millimeter mercury, the volume was 300 centimeter cube. Now for 750 millimeter mercury, your answer must be what? Greater than V1. Now let's assume your P2 is 950. It means your answer must be what? Must be lesser to 300 centimeter cube. Now if you are calculating this problem and you are getting something lesser than 300 centimeter cube, it means you are wrong, because the pressure is reducing. If the pressure is reducing, your volume must increase. So our V here for final volume is what? 360 centimeter cube. Now let's look at the third question. The third question says a gas initially at 273 Kelvin is heated such that its volume and pressure become twice their original values. What is the new temperature of the gas? Now let's write out the parameters first. A gas initially at 273 Kelvin, it means T1 is equal to what? 273 Kelvin. Such that its volume and pressure become twice their original values. The pressure and volume become 2 times. That's the meaning of twice. 2 times their what? Their original values. Now if you look at this question, we were not given the original values. Ordinarily, any student would have just concluded that we have just 273 Kelvin. The parameters is not what? It's not complete. But looking at the statement, the parameters is complete. But just that you need a true meaning, a true understanding of the what? Of the question. Now, twice their original values, which means you can decide to take anything as the original values. If you are taking the original value to be 1, it means your new value will be 2 times 1. Let's put down to writing. Now, for V1 and P1, such that its volume and pressure become twice their original values. Let's assume I'm using 1 centimeter cube as my original value, and for pressure I'm using 180 M as my original pressure. It means for V2 from the question, such that its volume and pressure become twice their original value, it means my V2 will now be 2 times 1 centimeter cube. Now if you decide to use letter that okay, your original value is V, it means your V2 will be what? 2 times V. That would be 2V. But here I'm using 1 centimeter cube. You can also calculate and make use of V, and your V2 will be what? Will be 2V. You can also calculate, you are going to get the same answer. Now for pressure, it means my pressure is also 2 times 180 M. Right? Now the question says, what is the new temperature of the gas? That is the T2. We are looking for what? T2. Now looking at the parameters, we have pressure, we have volume, we have temperature. And which of the law comprises of these three parameters? That is the general gas law. So we are using the general gas law equation. Now let's input our values. Our P1 is 1, multiplied by our V1, 1, over our T1 is 273. Our P2, 2 times 1 centimeter, that's 2. Multiplied by 2 times 1, that's 2. Our temperature, unknown, which is what we are looking for. So then the what? It was multiplied. 1 times 1 is 1. Multiplied by x is what? X. Now this 273 multiplying this 2 times 2 is what? 4. So we have x equal to what? 273 times 4. Our x is equal to 2. So we have our x is equal to what? 1092 Kelvin. Now let's look at the fourth question. The fourth question: the pressure of a gas that occupies a volume of 600 centimeter cube at 87 degrees Celsius is 900 millimeter mercury. Stop. What is the pressure of the gas at minus 33 degrees Celsius if the volume is reduced to 300 centimeter cube? Now let's write out our parameters. Now the question says the pressure of a gas that occupies a volume of 600 centimeter cube. It means our V1 is what? 600 centimeter cube at 87 degrees Celsius. That is our T1 temperature, 87 degrees Celsius. Let's convert it to Kelvin. That's plus 273 Kelvin. 273 plus 87. Now, is 900 millimeter mercury. That is our P1. 900 millimeter was mercury. What is the pressure of the gas? What is the pressure? That is a question. It is a question. It is asking a question. What? It means we are looking for our P2. What is the pressure of the gas at minus 33 degrees Celsius? Our temperature, minus 33 degrees Celsius. Let's convert that to Kelvin also. V2, if the volume is reduced to 300 centimeter cube. Here we have 87 degrees Celsius plus 273 Kelvin. That is 360 Kelvin. Now here minus 33 plus 273. That is indirectly saying 273 minus 33, right? 273 minus 33, and that is 240 Kelvin. So in this question we have the three parameters. We have P1, we have volume, and we have temperature, which means we are making use of the general gas equation. P1 V1 over T1 equal to P2 V2 over T2. Now our P1 is 900, our V1 is 600, all over our T1 is 360, our P2, which is what we are looking for, our V2 300, and our T2 240. Now let's cross multiply. Now for this 360 multiplied by P2 times 300, we have 1296,000,000 equal to 360 300p. So here we have 1296,000,000 equal to 360 times 300. 360 multiplied by 300. That is 108,000p. So we are going to divide both sides by the coefficient of what? Of p, which is 108,000. Divide this by 108,000. So we have our p equal to 1,200 millimeter mercury. So if you look at the process, it is very simple. It is a very simple thing. The first thing is to what? Is to get your parameters, identify your parameters, and after that, identify the kind of law you are using, either Boyle's law or Charles law or what, or the general gas equation. Now let's look at the last question, the number 5 question. The last question says a gas occupies a volume of 0.75 dm cube at 27 degrees Celsius and 0.9 atm. Full stop. The volume of gas at 75 degrees Celsius and 0.9 atm is dash. Now let's write the parameters one after the other. Volume of 0.75 dm cube. I mentioned earlier also that our volume is measured in what? In centimeter cube, in dm cube. Now our volume V1 is equal to what? 0.75 dm cube at 27 degrees Celsius. T1 27 degrees Celsius. Let's convert that to Kelvin. plus 273 Kelvin, and that is 300 Kelvin, right? Now, and 0.9 atm, that is our pressure, 0.9 atm. The volume of gas at 75 degrees Celsius. Now the question is asking us that what is the volume of that gas at 75 degrees Celsius? 75 degrees Celsius plus 273. Don't forget that we are converting from degrees Celsius to Kelvin. And 0.9 atm, it means our P2 is equal to what? 0.9 atm. We are looking for V2 x. 75 plus 273, that is 348 Kelvin. Now we have pressure, volume, and we have the temperature, which means we are using the general gas equation. Now let's input our values. We have V1 0.9 multiplied by V1 0.75 divided by 300 equal to our P2 0.9 multiplied by, we are looking for V2x over, what is our T2? 348 Kelvin. Now let's cross multiply. We have 0.9 multiplied by 0.75 multiplied by 348, that is 234.9 equal to, here 300 multiplied by 0.9, 270, that's 270x. Now we divide both sides by what? By the coefficient of x, which is 270. So we have 270. Our x is equal to 0.234.9 divided by 270, 0.87 dm cube. Now, if you are given a parameters in atm, let's assume you are given this volume in dm cube. Now your final answer should also be in dm cube for Waec candidates. Don't say because you were given dm cube, now you came here to write cm cube, you lose a mark. Now if you are given in dm cube, make sure your answer is also in what? In dm cube. If you are given your pressure in atm and you are calculating for pressure, leave your answer in what? In atm, unless if the question asks you to convert from one unit to another. So we have come to the end of today's class, and we've been able to discuss Boyle's law, Charles' law, and the general gas equation. Now in our next class, we are going to be talking about other laws, because that's not the two laws we have. We have Jamb's law of derivation, and we have Gay-Lussac's law. We also have Dalton's law of partial pressure. So in our next class, we are going to be looking at Gay-Lussac's law, Jamb's law, and Dalton's law of partial pressure. And if this is your first time of watching us, you are welcome to the Scholar online class. Make sure you click the subscribe button and also the bell button to get notification from us. Thank you.